Time for a little Friday fun, hooking up a pinball machine to Fabric Real-time Intelligence. While playing a game, I thought pinball is a pretty good example of a structured data stream, so the goal was to test how quickly I could prototype a solution. To do this, we'll need to capture events from a custom map from a pinball machine, which in this case is emulated using Visual Pinball and VPinmame. We'll reference a service manual for switches like the shooter lane and other details, send those events to an event hub, process them in an event stream, store them in an event house or KQL database, and then ultimately present them in a report. I wrote a simple C# app to send the events to the stream and ultimately into the event house. If we start a game, we can see that we have about a 3-second latency for this to be reflected on our report. This is pretty fast considering that there are several isolated processes handling the data, but to understand this a bit better, we can look at some data points. These are some approximate latencies. The app uses a simple queue without any kind of persistent connections and does not do any kind of batch or micro batching of the events, and so this can introduce quite a bit of latency due to the amount of volume, and so it would need to be redesigned. The latency of the event hub and event stream are both very low, and this is using only a basic event hub, and the Fabric capacity is used for several demos, so it might have some variability. Direct ingestion, though, helps significantly, but the bulk of the delay is on the Power BI side, as the Power BI report needs to poll the KQL database for any updates. We can stress the latency by artificially dragging the ball around and saturating the event queue. As events queue, the delay increases as the time to process each event exceeds the app's capacity. With potentially thousands of events per minute, there are a few approaches we could take, such as maintaining a stateful connection, batching or micro-batching, or more realistically, using a Lambda architecture to split the data, which we'll discuss more later. Once we allow the queue to catch up, latency comes back down, so clearly an app in this case would need to be redesigned. With the game complete, we can break down the events a bit, and we'll do that in another report. More on this in a moment, but the first thing that jumps out is this right in-lane switch that's triggered significantly more than the other lanes. This is expected on this game because every ball that is played will trigger this switch, which is somewhat unusual. We could create a measure that subtracts balls played from this number if we wanted to see the data normalized. This simple report will show a few other statistics like the balance of each flipper and slingshots and how the data compares to overall average across all games. With the original POC done, let's refine this a bit for a POV. I would use a Lambda architecture, as mentioned earlier, to split the data into a hot and cold path because the machine is generating hundreds or even thousands of events per minute. Critical data can be sent on the hot path to the event hub, while aggregated data at the end of each game can be compressed into an ORC or Parquet file and saved as a blob in one lake. In either case, an event stream is triggered to process the data. A data activator could be notified for a detected anomaly, while the data is stored in the event house and refined using update policies into a medallion-like architecture. Data can be fed into our ML models for proactive machine maintenance. Now, of course, these machines are all independent, but if they were part of a larger system, this is where we could build an ontology using Digital Twin Builder in order to better model the entire system to give a more holistic view. We'd use data agents to supplement the reports to enable better analytics, and finally, I would enable two types of reporting here, Power BI for the analytics, while we would use real-time dashboards for operations. Okay, so maybe this isn't something arcades necessarily need, but conceptually we can see how this type of system can help in rapid detection of errors, preventative maintenance, deeper analytics, and even product design, as the telemetry reveals quite a bit on product usage. Not a bad result for a day's work, so I'm going to grab a beer and play some pinball.